Shalom. Thank you for tuning in. Would like to proceed with our paper, June 2021, paper 3. Right. We are now moving on to question number 7. It reads, the diagram shows the curve y is equals to arctan of x divided by square root of x and its maximum point M, where x is equals to a. Right. Show that a satisfies the equation a is equals to tan open bracket 2a divided by 1 plus a squared, 4 marks. Right. So there is a word that I want you to understand, this given word, maximum point. Right. I want you to notice that at maximum point dy dx is equals to 0. Whenever you hear the word maximum point or a minimum point or a stationary point or a turning point, you need to understand that dy dx is equals to 0. Right. So what I want you to do is you take y is equals to arctan of x divided by square root of x like this. Then you find dy dx. Then you equate the dy dx to 0 to find the maximum. I hope you are listening. Right. So dy dx is equals to, so since we have a numerator and a denominator and the functions are different, we have algebra and the trig above, we can make use of quotient rule. Right. So under quotient rule, what you need to do is you square the denominator first. So the denominator is root x, you raise it by 2. Then you write root x, the denominator as it is first on your numerator. You put a dot product. Right. So on the dot product, we would like to find the derivative of arctan of x. So the derivative of arctan of x is 1 over 1 plus x squared. I hope you are listening, class. Right. The derivative of arctan of x is 1 over 1 plus x squared. This is coming from the fact that if you integrate 1 over 1 plus x squared dx, your answer is arctan of x plus c. So if we are to find the derivative of arctan, remember, differentiation is the reversal process of integration. So derivative of arctan of x, you get 1 over 1 plus x squared. This is where it is coming from. I hope you are following, class. Then you put a negative sign like this. So we now want to find the derivative of root x. So you start by writing the numerator, arctan of x as it is, then you put a dot product. So acknowledge that root x is good as x to the power of half. So to find the derivative of x to the power of half, you start by multiplying. There is a silent one here, so half times 1 you get half. You put x, then you less half with 1. So you come out with half x, half minus 1, you get minus 1 over 2, which can be written as 1 over 2 root x, applying the laws of indices. I hope you are listening, class. Right. So this dy dx, I am going to equate it to 0, since at maximum point dy dx is 0. So I want you to notice something, class. We are going to do the process of cross multiplication, or to take root x squared as our LCM and multiply both sides. You will be left out with root x times 1, you get root x over 1 plus x squared, right, on your left side, minus arctan of x, right, dot product 1 plus 2 root x is equals to 0. I hope you are listening, right? So we now want to make arctan of x the subject of the formula. So to make arctan of x the subject of the formula, let me move arctan of x dot product 1 over 2 root x to the right side. So you have root x over 1 plus x squared is equals to arctan of x dot product 1 over 2 root x, like this, right? Then we do the process of cross multiplication. Start by acknowledging that arctan of x is going to multiply 1 to get arctan of x divided by 2 root x. Then you do the process of cross multiplication. I hope you are listening, right? So if we multiply root x with the 2 root x, then you divide by 1 plus x squared, you will be able to make arctan of x the subject of the formula, right? So applying the laws of sets, if you multiply common sets, take for instance, you multiply root 3 times root 3, you get 3 as your answer. So if I'm to multiply root x times root x, I'm going to get x as my answer. So root x times root x, you get x. X times 2, it means you now have 2x on your numerator. Divide this by 1 plus x squared. Equate it to arctan of x. I hope you are listening, right? So to make x the subject of the formula, you need to remove this arctan. So I want you to notice something, guys. Let's say you have tan theta is equals to 3/4. Remember, to make theta the subject, you say arctan of 3/4. But if you want to go backwards, it means this arctan is going to become tan theta is equals to 3/4. Same applies. I want to make x the subject, so I'm going to remove this arctan. But if you place arctan on your left side, you have tan. I hope you are following. Then you put open bracket, right, 2x divided by 1 plus x squared. We have made this x, right? So remember, the condition here is its maximum point M where x is equals to a. So it means every letter x I'm going to put a. Therefore, my final answer becomes tan, open bracket, 2a over 1 plus a squared is equals to a. Then you have managed to show this requirement. I hope you are listening. So I want you to stay tuned as we move on to part B. Right, we are now on part B. It reads, verify by calculation that a lies between 1,3 and 1,5. Right. So remember, in the previous part we got a is equals to tan, open bracket, 2a over 1 plus a squared. Right. So to verify by calculation, you start by moving all the terms to the same side so that you create a 0 on the other side. So let me move tan on the left. You get tan, right, open bracket, 2a over 1 plus a squared is equals to 0. Something like this, right? Then create an expression for f of a. So f of a is equals to a minus tan, open bracket, 2a over 1 plus a squared, something like this, right? So to verify by calculation, right, you first of all calculate f of 1,3, this lower limit here. put 1,3 on each and every letter in A. You get 1,3 minus tan, open bracket 2, open bracket 1,3 all over 2, 1 plus 1,3 squared. Right. So if you punch this in your calculator, you get minus 0,1484. I hope you are following class. Right. So you need to do the same. The upper limit is 1,5. Here is 1,5. So you also find f of 1,5. Substitute 1,5 on each and every letter in A. You get 1,5 minus tan, open bracket 2, times 1,5 over 1 plus 1,5 squared. Then if you punch this in your calculator, you get 0,1783. Right. So you can notice that there is a sign change. Right. F of 1,3 is giving us a negative result. F of 1,5 is giving us a positive result. So you then give your conclusion. You say that since a sign change denotes, right, a sign change denotes that A lies between 1,3 and 1,5, then you are home and dry. Right, we are now moving on to part C. It reads, use an iterative formula based on the equation in part A to determine A correct to 2 decimal places. Right, give the result of each iteration to 4 decimal places. Right, so the equation in part A is the one which is A is equals to tan, open bracket 2A divided by 1 plus A squared. Right, so to use the iteration, right, you make use of A, right, then you drop n plus 1 is equals to tan, open bracket 2A drop n, 1 plus A drop n squared. Right, so you need to start by identifying what you call the initial value. Right, so the initial value is not given in this question like what they used to do. Right, so what you need to do, the convenient value that you can make use is the average of the lower limit and the upper limit. So 1,3 plus 1,5 divided by 2, you get 2,8 divided by 2, which is equals to 1,4. So 1,4 is this initial value that you can make use of as A0. Right, so I'm going to take A0, the initial, is 1,4, which is the average of the lower limit and the upper limit. I hope you are getting it, class. Right, so you have to find A1, A2, A3, A4 until the 2 decimal places required starts to recur. I hope you are following, class. Right, so A1 is going to be found by substituting 1,4 on A drop n, A drop n. I hope you are following. Right, so you get tan, open bracket 2, then you put 1,4 here, 1 plus 1,4 squared. So if you punch this in your calculator, you get 1,3865, since each iteration is to be placed in 4 decimal places. Right, I hope you are listening. Right, then if you substitute 2, open bracket 1,3865 over 1 plus 1,3865 squared. If you punch this in your calculator, it gives you 1,3951. I hope you are listening, class. Right, then if you substitute 1,3951 divided by 1 plus 1,3951 squared. And if you punch this in your calculator, you get 1,3896. I hope you are listening. Right. Then you move on to A4. If you substitute 1,3896, then divide with 1 plus 1,3896 squared, right? You get 1,3931, right? You can even use your calculator to backspace this 1,4. Then you put 1,386165 to get the corresponding. Then you do up to and until you see the recurrence. I hope you are following, right? If you do this on A5, right? On A5 you get 1,3908. If you substitute 1,3931, you get 1,3908. So you can notice that if we are to make A to 2 decimal places, 39 is the 2 decimal place that is recurring. Therefore, A is equals to 1,39, and this is your final answer. So you have to do at least 4 iterations until the 2 decimal place required is recurring. So 1,39 and 1,39 is recurred. I hope you are listening, class. So I want you to stay tuned as we move on to question number 8. Right, we are now moving on to question number 8. It reads, with respect to the origin O, the points A and B have position vectors given by OA is equals to 1, 2, 1, and OB is equals to 3, 1, minus 2. The line L, right, has equation R is equals to 2, 3, 1 plus lambda 1 minus 2, 1. So this is the vector equation line, and you need to understand the meaning of these column vectors. These represent the point which is lying on the vector line. Then this represents the direction of the vector. I hope you are following, right? So to find the acute angle between the directions AM and L, you start by calculating AB. So AB is going to be calculated by the formula OB minus OA. OB in front minus OA, right? So the position vector of OB is given as 3, 1, minus 2. You write 3, 1, minus 2 like this. Then the position vector of OA is given as 1, 2, 1. So you write 1, 2, 1 like this. So 3 minus 1, you get 2. 1 minus 2, you get minus 1. Minus 2 minus 1, you get minus 3. So this is AB, right? So this direction AB, I'm going to make use of this direction AB together with the direction of the line to calculate the angle required, right? So let the angle be represented by theta, right? So you write cos theta is equals to dot product of AB, which is 1, which is 2, minus 1, minus 3, with the direction of the line, which is 1, minus 2, 1. Then you divide by the modulus, right, of the corresponding vectors. So you have 2 squared here, plus minus 1 squared, plus minus 3 squared. Here you have 1 squared here, plus minus 2 squared here, plus 1 squared. I hope you are listening, class, right? So you write cos theta is equals to 2 times 1, you get 2. Minus 1 times minus 2, you get 2. I hope you are listening. Minus 3 times 1, you get minus 3. This is your numerator, right? Then on the denominator, we are going to simplify the square roots of the modulus. So 2 squared plus minus 1 squared plus minus 3 squared, you get 14 here. This is 14. Then I'm moving to the next modulus. 1 squared plus minus 2 squared plus 1 squared. This is 6, right? You get 6, right? So 14 times 6, it gives you 84. It means if I write cos theta like this, I'm going to put square root of 84 as my denominator, where 84 is 14 by 6, right? Then 2 plus 2, you get 4. 4 minus 3, you get 1. To find the angle, you create arc cos on the right side, so as to make theta the subject of the formula. Then put 1 over square root of 84 inside the bracket. Then make sure that your calculator is in degrees, right? So arc cos of 1 divided by square root of 84, you get 83.7 degrees, which is the acute angle. Remember, acute angle is the angle between 0 and 90 degrees. So 83.7 degrees is less than 90. And this is your answer. You are home and dry. I hope you are listening, class. So let us move on to question number 8b. Right, we are now moving on to part B of the question. It reads, find the position vector of the point P on L. Remember, L is this line, right? Such that AP is equals to PP. So the question gave us the position vector of A and the position vector of B, as well as the line L, which is 2, 3, 1 plus lambda 1 minus 2, 1, right? So if you are to combine this point together with this direction, I hope you are following, you get the position vector of P in terms of lambda. So let the position vector of P in terms of lambda be represented by 2 plus lambda times 1, you get lambda. 3 lambda times minus 2, you get minus 2 lambda. Then you write 1 lambda times 1, you get lambda. So 2 plus lambda, 3 minus 2 lambda, 1 plus lambda denotes the position vector of OP in terms of lambda, right? So if AP is equals to BP, it means the modulus of AP is going to be equivalent to the modulus of BP. I hope you are following, right? So I'm going to find AP first, right? Using the formula OP minus OA, right? Where OP is going to be denoted by 2 plus lambda, 3 minus 2 lambda, 1 plus lambda, right? Then OA is the position vector given here, 1, 2, 1, right? So 2 plus lambda minus 1, you get 2 minus 1, it's 1 plus lambda. 3 minus 2 lambda minus 2, you get 3 minus 2, you get 1 minus 2 lambda. I hope you are following. Then 1 plus lambda minus 1, you get 1 minus 1 is 0, so you'll be left out with the lambda. So this is AP for you, right? Then you find BP. BP is equals to OP minus OB, right? So OP is 2 plus lambda, 3 minus 2 lambda, 1 plus lambda. Then OB is 3, 1 and minus 2. So you have 3, 1 and minus 2 for OB. I hope you are following, class. So 2 plus lambda minus 3, you get 2 minus 3, it's minus 1 plus lambda. 3 minus 1, you get 2 minus 2 lambda. 1 minus minus 2 is 3. Since minus and minus, you get a positive. So it's 3 plus lambda. I hope you are following. Right. So modulus of AP is equivalent to modulus of BP to satisfy this condition. AP is equals to BP. Right. So the modulus of AP is square root. Right. Remember, AP is 1 plus lambda. So you write 1 plus lambda squared. Then we have 1 minus 2 lambda. 1 minus 2 lambda squared plus lambda squared. Right. Then on BP, you put square root again. So this is BP. You have minus 1 plus lambda squared plus 2 minus 2 lambda squared plus 3 plus lambda squared, something like this. So since you have square root both sides, you can ignore the root signs, right? Because they are appearing both sides, so you ignore them, right? So you'll be left out with 1 plus lambda squared plus 1 minus 2 lambda squared plus lambda squared. Then on the right side, you have minus 1 plus lambda squared plus 2 minus 2 lambda squared plus 3 plus lambda squared. Right. So I would like to expand the brackets. So 1 squared is 1. Then 1 times lambda times 2, you get 2 lambda, the middle term. Then lambda squared. Right. 1 squared is 1. 1 times minus 2 lambda times 2, you get minus 4 lambda. Minus 2 lambda squared is plus 4 lambda squared plus lambda squared. So you are done on the left side. We move on to the right side here. The first term here is minus 1 squared. Minus 1 squared is 1. Minus 1 times lambda times 2, you get minus 2 lambda. Lambda squared, you get lambda squared. We move on to the second bracket. 2 squared is 4. Minus 2 times minus 2, you get minus 4 times 2, you get minus 8 lambda, the middle term. Then minus 2 lambda squared, it gives you 4 lambda squared. Right. We move on to the last bracket. 3 squared is 9. 3 times lambda times 2, you get 6 lambda. Right. Then lambda squared, you get lambda squared, something like this. I hope you are following. Right. So I would like to cancel out common items which are being found both sides. Right. Take for example. Right. We have 4 lambda squared here. This 4 lambda squared is going to cancel out with this 4 lambda squared. I hope you are following. We also have lambda squared on the right side. So lambda squared is going to cancel out with the lambda squared on the left. I hope you are following. Then another lambda squared on the right here is going to cancel out with another lambda squared here. I hope you are following. Then 1 here, 1 is going to cancel out with this one. Right. Do you still have another common item here? No, we no longer have common items here. So on the left side, you'll be left out with 2 lambda plus 1 minus 4 lambda. Right. The terms left, right, equal sign. Here you'll be left out with minus 2 lambda here, plus 4 minus 8 lambda plus 9 plus 6 lambda. So we now have 2 lambda plus 1 minus 4 lambda is equals to minus 2 lambda plus 4 minus 8 lambda plus 9 plus 6 lambda. Right. So 2 lambda minus 4 lambda, you get minus 2 lambda plus 1. Right. Then minus 2 lambda minus 8 lambda, you get minus 10 lambda. So minus 10 lambda plus 6 lambda, you get minus 4 lambda. I hope you are following. Then 4 plus 9, it gives you 13. All right. So let us collect like terms. We are going to move minus 4 lambda to the left side. You get 4 lambda minus 2 lambda. I hope you are following. Then you move 1 to the right side. You get 13 minus 1. Right. So 4 minus 2 lambda, you get 2 lambda, right? Then 12 is the answer on the right side. 13 minus 1 is 12. Divide both sides by what? By 2. Therefore, lambda is equals to 6. I hope you are following. Right. So to then find the required position vector of P such that AP is equals to BP. Remember, the position vector of P is being denoted in terms of lambda, which was found by combining these two, right? So we now need to substitute 6 on each and every lambda, right, to find the position vector of OP, right? So you now have 2 plus 6, 3 minus, right, 2 times 6 is 12. Then 1 plus 6, right? So you have 8. 2 plus 6 is 8. Then 3 minus 12, you get minus 9. Then 1 plus 6, it gives you 7 as your position vector, which can be presented as 8i minus 9j plus 7k. Then you are home and dry. I hope you are listening, class. So I want you to stay tuned as we move on to the next question. Right, we are now moving on to question number 9. It reads, the equation of a curve is y is equals to x to the power of minus 2/3 ln x for x is greater than 0. Right, take note of that. Why x is greater than 0? Remember, there is no ln of 0. I hope you are listening. Right. The curve has one stationary point. Right. So in question number 7, I highlighted that stationary point is found when dy dx is 0. Do not forget that. Right. So find the exact coordinates of the stationary points. So to find the stationary point, I need to find dy dx, then equate dy dx to 0. I hope you are listening. Right. So you can make use of product rule here to find the dy dx. Start by writing x to the power of minus 2/3 as it is, put dot product. So derivative of ln x is 1 over x. I hope you are listening. Right. Then you put a plus, then you write ln x as it is, put dot product, so that you find derivative of x to the power of minus 2/3. So you get minus 2/3 first, then minus 2 over 3, you less it with 1. I hope you are listening, class. Right. So dy dx is equals to x to the power of minus 2/3, right, divided by x, something like this, right, plus, right, ln x, open bracket, minus 2 over 3. So minus 2 over 3 minus 1, you get minus 5 over 3. So x to the power of minus 5 over 3, something like this. I hope you are listening. Whenever you divide numbers with the same base, you subtract the powers, right? So dy dx, right, is equals to x, right? So you say minus 2 over 3 minus 1. What is minus 2 over 3 minus 1? You get minus 5 over 3. I hope you are listening. right? Then plus times minus, you get minus. Then this is x to the power of minus 5 over 3 ln x. Then we have 2 over 3 here, right? So ln x times minus 2 over 3, x to the power of 5 over 3, you get minus 2 over 3, x to the power of 5 over 3 ln x. I hope you are listening, right? So remember, stationary point is found when dy dx is equals to 0. I'm going to equate this to 0, right? X to the power of 5 over 3 becomes the highest common factor. So let me factorize. You put open bracket here. So x to the power of minus 5 over 3 into x to the power of minus 5 over 3, you get 1 minus 2 over 3 ln x is equals to 0. I hope you are following, class, right? So when two terms multiply each other to produce 0, you are going to create two separate equations. The first equation is x to the power of minus 5 over 3 is equals to 0, right? Or the second equation is 1 minus 2 over 3 ln x is equals to 0. I hope you are following, class, right? So this first equation is going to be invalid, right? Why? Because the value of x, which makes x to the power of minus 5 over 3 to become 0, is 0. But there is a condition on the question that x must be greater than 0. So 0 is not greater than 0. Hence, this first equation is invalid. So the exact coordinates are going to be found by the second equation. So I'm going to move 2/3 to the right side. You get 1 is equals to 2 over 3 ln x, something like this. I hope you are following. Then you multiply both sides by 3 over 2 to make ln x the subject of the formula. I hope you are following. Raise both sides by exponential. So it's e to the power of 3 over 2 is equals to x. So this is the x coordinate. I hope you are listening, right? But for a coordinate, we must have the x coordinate and y coordinate. So to find the y coordinate, you move back, right, to the original function given, which was y is equals to minus 2x to the power of minus 2/3 ln x. Substitute e to the power of 3 over 2 on each and every term in x. You get y is equals to x, which is e to the power of 3 over 2. You put bracket, raise this by minus 2/3. I hope you are following. Ln e to the power of 3 over 2, where e to the power of 3 over 2 is representing x. I hope you are following, class, right? So 3 over 2 times minus 3 over 2, it gives you minus 1, right? Then dot product, right? Making use of the power rule, I'm going to bring down 3 over 2. You get 3 over 2 ln e, where ln e is good as 1. So the y coordinate becomes 3 over 2 e to the power of minus 1, which can be written as 3 over 2e, making use of the laws of indices. Therefore, our final answer must have x and y, right? X is e to the power of 3 over 2, right? Then y is 3 over 2e. And this is the coordinate for the stationary point. I hope you are listening, class. So I want you to stay tuned as we move on to the next equation. Show that integral of 8 upper limit 1 lower limit y dx is equals to 18 ln 2 minus 9. right? So remember y was given as x to the power of minus 2 over 3 ln x, something like this. I hope you are listening, right? So I'm going to put my integral sign first. 8 is my upper limit, 1 lower limit. Then on y, replace y with x to the power of minus 2 over 3 ln x dx, something like this. So I would like to work it out till we get 18 ln 2 minus 9. I hope you are following, right? So for this one, you make use of integration by parts, right? I normally use the troubleshooter, which we refer to as let, right? Let is more of a board mass of integration by parts, right? It helps you to determine the value or the function which is going to represent u, right? Remember, integration by parts, it says that uv minus integral of du dx dot product v dx. This is the formula of integration by parts. So to identify the u, you make use of the let order, right? Where L represent logs it's ln, A represent the algebraic expressions. In this case, our algebra is x to the power of minus 2/3. T stands for trig ratios. E stands for exponential, right? So the first function, right, in this order of let is going to represent our u. So in our question, we have the algebraic side, we have the log side, right? So on our let formula, you can notice that L, right, has got the first preference. So it means ln x is going to represent our u. So you find du dx, right? So derivative of ln x is 1 over x. I hope you are following, right? Right. So the remaining, right, function, which is x to the power of minus 2/3, is going to help you to find the value of v if you are to integrate the remaining function, right? So v is equal to integral of x to the power of minus 2 over 3 dx, right? So when integrating algebraic expressions of this kind, you add 1 on the power, then you divide everything by the new power, right? So if we add 1 on minus 2 over 3, you get 1/3, right? So dividing by 1/3 is good as multiplying x to the power of 1/3 by 3. So you get 3x to the power of 1/3. I hope you are listening, right? So we now want to substitute in the formula uv, right, minus integral of du dx dot product v dx. So what is our u? Our u is ln x. So I'm going to put ln x to represent u, then put dot product here, right? Then v is 3x to the power of 3rd, which is the integral of the remaining function, right? So you have 3, right, x to the power of 1/3. Put negative sign, put integral, right? Du dx is 1 over x, which is here, right? Then dot product, then v is 3x to the power of 1/3 dx. I hope you are listening, class, right? So let me then write this as 3x to the power of 1/3 ln x minus integral of, right? So remember, here you are dividing x to the power of 1/3 with x. When dividing numbers with the same base, you subtract the powers. So it's more like you are saying 3x to the power of 1/3 divided by x to the power of 1. So you get 3x to the power of 1/3 minus 1, you get minus 2/3, right? So we have 3x to the power of minus 2 over 3 dx. I hope you are listening. We would like to integrate this. So maintain 3x to the power of a third ln x on your left. You put minus. Then to integrate this, you add minus 2/3 by 1. Then you divide by the new power. So if we add minus 2/3 by 1, you get 1 over 3. Then you divide by 1 over 3. So dividing by 1 over 3 is good as multiplying by 3. So if we are to reduce this further, we reach at 3x to the power of a third ln x minus 3 by 3, you get 9x to the power of a third, something like this. I hope you are listening, class, right? So 3 cube root of x ln x minus 9 cube root of x, right? Don't forget that we have the limits 8 and 1, right? So to find the answer now, it is now a matter of substituting the upper limit in the first bracket. Then you less the result with the substitution of the lower limit in the second bracket. I hope you are listening. So let me start by substituting the upper limit, which is 8. So you get 3 cube root of 8 ln 8 minus 9 cube root of 8, right? Then in the second bracket, you get 3 cube root of 1 ln 1 minus 9 cube root of 1, right? So what is cube root of 8? Cube root of 8 is 2. You have to multiply 2 with these 3, right? You get 6 ln 8 minus cube root of 8 is 2, so 2 times 9 here, you get 18. I hope you are listening. Put negative here, you put your bracket. Remember, whenever you see ln 1 is 0. So 3 cube root of 1 ln 1, you are going to get a 0 minus, right? Cube root of 1 is 1 times 9, we get 9. Right. So we now have 6 ln 8 minus 18. Minus and minus, you get plus 9, something like this. I hope you are listening. So ln 8 can be written as 2 to the power of 3, since we have 2 on our show that. Minus 18 plus 9, you get minus 9. So making use of the power rule, you need to bring down this 3 to multiply this 6. So 3 times 6, you get 18. I hope you are listening. So it's now 18 ln 2 minus 9. Then you are home and dry. So this is how you show. I hope you are listening. So I want you to stay focused as we move on to the last question of the paper. The variable x and t satisfy the differential equation dx over dt is equals to x squared open bracket 1 plus 2x, and x is equals to 1 when t is equals to 0. Using partial fractions, solve the differential equation, obtaining an expression for t in terms of x, meaning to say that we would like to make t the subject of the formula after solving the dE, right? So when solving a differential equation, we have dx dt, right, is equals to x squared 1 plus 2x. You collect like terms, right? So let me start by cross multiplication. You get the x is equals to x squared 1 plus 2x dt. Divide both sides by x squared 1 plus 2x. You get 1 over x squared 1 plus 2x dx then you'll be left out with the dt on the right side. After that, introduce integral signs both sides. So we want to make use of partial fractions, right? How do you make use of partial fractions? Right, we have 1 over x squared, right? 1 plus 2x, right, is identical to x squared can be represented by a repeated factor. So you can write this as a over x plus b over x squared, something like this. Then 1 plus 2x is a linear factor. So c 1 plus 2x. I hope you are following, right? So a open bracket x into this denominator of x squared 1 plus 2x, you get 1 plus 2x and x. I hope you are listening, right? Then you put a plus x squared into this denominator, you get 1 plus 2x to multiply this b. So b is going to be multiplied by 1 plus 2x, right? Then we move on to c. 1 plus 2x and 1 plus 2x, they cancel out each other, leaving you with x squared to multiply c. So you have cx squared. This is identical to this one, right? So we'd like to find the values of a, b, and c, right? We can start by saying let x be equivalent to 0. You will be able to eliminate a and c. Since if you put 0 on x, everything becomes 0 on the a side. If you put 0 on x squared, c also becomes 0. So if x is 0, it helps you to find the value of b. So you now have b, open bracket. If you put 0 on 2x, 2x becomes 0. So you'll be left out with the 1 here. Is equals to 1 on the right side. Therefore, b is equals to 1. I hope you are following, right? Then you can also find another value of x which can eliminate this bracket of 1 plus 2x, right? So to eliminate 1 plus 2x, you can make use of x is equals to minus half. If you put minus half on 2x, you get minus 1, right? So this will help you to find c, since you'll be able to eliminate a and b, right? So you write c, open bracket, minus half squared, then you equate this to 1, right? So minus half squared, it gives you 1/4. So it's 1/4 of c is equals to 1. If you cross multiply, therefore c is equals to 4. I hope you are listening. We are now left out with only one value, which is the value of a. The value of a, you can make use of x is equals to 1 if you want, or you can equate the coefficients of x squared. So we have the first coefficient of x squared, which is going to be produced if x multiplies 2x and then a. So x times 2x, you get 2x squared. 2x squared times a, you get 2ax squared. So it means the first coefficient of x squared is 2a, right? But on b, we do not have anything in x squared. You have to add with c, since we have c x squared. Then equate this to 0, since on the right side we don't have anything with x squared. So 2a plus c is equals to 0. But remember c, we have found it as 4. So it's 2a plus 4 is equals to 0, which gives you 2a is equals to minus 4. If you divide both sides by 2, therefore a is equals to minus 2. I hope you are following, class. Right? So we want to substitute this in our integral here. A is minus 2. So minus 2 over x. Then b is 1. So plus 1 over x squared. Then c, the value of c is 4. So you say plus 4 over 1 plus 2x dx. Something like this. You equate it to integral of dt. There is a silent one here. I hope you are following, right? So integral of minus 2 over x is minus 2 ln x, right? Then integral of 1 over x squared, you start by expressing 1 over x squared as x to the power of minus 2. So if you add 1 on minus 2, you get minus 1, then you divide by minus 1. So you get minus x to the power of minus 1. Then integral of 4 over 1 plus 2x is 4 divided by derivative of 1 plus 2x is 2. Right, ln modulus 1 plus 2x, something like this, is equals to integral of 1 is t, then plus c. I hope you are following, right? Right. What you can do now is you want to make t the subject of the formula, right? So let me move c to the left, or you can start by finding the values of what? Of c, using the initial values here, right? X is equals to 1 when t is equals to 0, right? So let me put 1 on x, right? You get minus 2 ln 1 minus 1. Since 1 to the power of minus 1, you get 1, plus 4 divided by 2 here, you get 2 ln modulus. If you put 1 on 2, you get 2 plus 1, it gives you 3 here, is equals to, remember when t is 0, put 0 on t plus c. I hope you are listening, right? So ln 1 is 0. You'll be left out here with minus 1 plus 2 ln 3 is equals to c. I hope you are following, right? So to make t the subject of the formula, I now need to move c on the left side. So you have 2 ln x. You have 2 ln x here, minus, this one can be written as 1 over x here, plus 2 ln modulus 1 plus 2x is equals to t plus c, where c is minus 1 plus 2 ln 3. I hope you are following. So I want to move minus 1 and 2 ln 3 on the left side. So you have minus 2 ln x minus 1 over x plus 2 ln 1 plus 2x here. If you move minus 1, you get plus 1, right? If you move 2 ln 3 to the left, you get minus 2 ln 3. Then you will be left out with the t. Then you are done. Since the question is requiring you to make t in terms of x, you are done. You get yourself 11 marks. I hope you are following, class. Thank you for watching. I want you to subscribe to my channel. Click the bell so that you don't miss new videos when posted. Till we meet again, shalom.